Hello everyone, hope all is well today. My name is Gilles Lamotte. Today we'll learn to do a paired t-test in R. So when do we use a paired t-test? Um, this will be in a context where for each statistical unit, and here if I look at my spreadsheet, in my first column I have patients, or these are subjects. An experiment, these are going to be the statistical unit. For each statistical unit we have two measurements, and so in that case we'll call them paired. They naturally go together because they come from the same unit. So here our units are actually patients or subjects that suffer from chronic pain. We would like to know if methadone on average would reduce their pain. And so the experiment was performed in the following way. For a certain amount of time, the patients were given a placebo, and we have a pain rating under the placebo. And then also for a certain amount of time, they were given methadone, and we have a pain rating under methadone. And we would like to know if on average methadone does reduce the pain. Okay, and so we're going to perform a paired t-test to verify this hypothesis. And so I'm going to save the data as a text file. I'll put it in my documents folder. The name of the file will be methadone, and save as text, which will be tab delimited. So I save the file. And then as I go to R, I'm going to create a data frame called data with the function read table. First argument will be file choose to force R to open a window to ask me where is the file. Then header equal to true. This is because I have names of columns in my first row in a file. And then sep, well, I need to tell R that I have tabs that separate my columns. So this is /t for tabs. Okay. And then as I enter my command, I try to find my file. This is under the documents folder, and I look for methadone. Okay, so I now have my file, and so I imported the data. To see the names of my columns, I use the function called names, and so I see placebo and methadone. Also patients, which is the subject IDs. Okay, so I'll create two numerical variables, one for the placebo, one for methadone. I'll call x for the use x for placebo, and so data is the name of the data frame, $ with the name of my column. This will create my first numerical variable, and then the second numerical variable, again, I use data, which is the name of my data frame, $, and then the name of my column, which is methadone. Okay, and so I have my paired measurements into two different numerical variables, and then now I will do a paired t-test. So I use a function called t-test. I will put x and y, so this is for placebo and methadone. And then I need to tell R that I have paired data, so paired is equal to true. And then as I enter the command, by default, we're going to be testing that the mean difference between the two paired measurements is equal to 0 against a two-sided alternative that it's different than 0. So here we have a p-value that's around the order of 1 in 1,000, which is very small. And so we have significant evidence against the null hypothesis in favor of a two-sided alternative. And so on average, the two pain ratings are different than each other. Okay, and we also have a 95% interval for the mean of the difference, which is somewhere between 4.8 to 17.4 about. Now, alternatively, if we did not have each of the measurements, but we actually had the difference between the two measurements, we could still do a paired t-test. And so here in the first argument, I will actually put the difference, so x minus y. And so now we don't need to tell R that the data is paired. So I just want to do a test on the mean of the difference. And again, we have the same result because it's the same paired t-test. Okay. Now, let's say that we wanted to test a stronger hypothesis, and we wanted to say that, or our research hypothesis was that methadone on average should reduce pain. And so methadone, which is the second variable, we're assuming that on average is going to be smaller than the first variable, which is the pain under the placebo. And so when I look at the difference, y is going to be smaller, and so the difference is going to be greater than 0. And so I want to put an alternative equal to, in quotation marks, greater. So this will be a right-sided alternative. And so again, we see that we have a p-value that's very small, and so we have significant evidence against the null hypothesis in favor of an alternative that the mean of the difference is greater than 0. So on average, we can conclude that the mean score for the placebo is larger than the mean score under the methadone. Okay. We could have tested a left-sided alternative by using alternative equal to less. And so this would be in a case where we would believe that on average the value for methadone would be larger than the value for the placebo. Okay. And of course here we see that the p-values are extremely large, and so we don't have strong evidence, or the evidence against the null hypothesis in favor of a left-sided alternative here is not significant. So this is how you do a paired t-test. Have a good night.